This is lesson 3.4.A, and today we will write linear inequalities. So our objectives are to write the linear inequalities given a graph. Let's first look at some key questions that we need to answer in order to help us to write these linear inequalities. So number one, how can you determine the equation for the boundary line? Remember that the boundary line is the equation of a line, and it separates the graph into two distinct parts. So how can we determine that equation? It's easy. If we determine the slope and the y-intercept from the graph, then we can write the equation in y equals mx plus b form. So number two, what do you need to consider when determining which inequality symbol to use? So remember, because these are inequalities, we can't have an equals here. We would need to have a greater than or equal to, or a less than or equal to, or a greater than or a less than. So what do we need to consider when determining which inequality symbol to use? What we need to consider is to determine whether the boundary line is dashed or solid. So hopefully that is familiar to you, and whether the shading is above or below the line. Remember that if the boundary line is dashed, we use a greater than sign or a less than sign. If it's solid, then we have a greater than or equal to, and then we also have a less than or equal to, so it would be one of those if it was solid. The shading above or below the line indicates whether we use the greater than or the less than. And finally, how can you determine, or how can you use test points to check your answer to determine whether or not you have the right equation? In order to do that, we will pick a test point in the solution area, so in the shaded area, or in the case of a system, in the overlapping shaded area, and then we will make sure it is true for all equations. So we can plug it in and make sure that it works for all equations. Let's try some examples. So let's go ahead and start with just one inequality. We have four graphs here, and we want to determine the equation of this inequality. So if we think about our questions, first thing is we need to determine the equation of the boundary line. In this first one, this dashed line is the boundary line. Well, if we look at our graph, it's a vertical line. It goes right through the x-axis. So if we count 1, 2, 3, 4, 5, this line goes through where x is equal to 5. So I'm going to go ahead and write my equation as x is equal to 5. Because this is an inequality, though, we know it's not going to be an equal sign. So we know then if I look at my line, it's going to be a less than or it's going to be a greater than. So if I look at where it's shaded on all the x's that are less than where this line is, right? Because here we have a -6, a -7, those numbers get smaller. So what we want for our final answer is for x, all the x's that are shaded are going to be less than, and I should say that's -5, not 5. And that'll be our solution to our first one. Now, in order to test to see whether this is in fact a solution, we should pick a point in the shaded area and make sure it's true. So let's go ahead and pick a point. I'm going to pick I only have an x, so I'm going to pick something on the x-axis. So I'm going to go ahead and pick this point right here. And that point is -6. So let's plug that in. So we have -6 is less than -5. And we just want to make sure that's true. And in fact, this is true. So our test point is fine, it works. That means our equation is correct. Let's go over here to the right and look at this one. In this problem now we have a horizontal line going through the y-axis. So anytime it goes through the y-axis, we know it's going to be a y equals something. Well, if we look at where it's going through where y is equal to 2. But now, since we have an inequality because we have the shading, This is all these points down here are in our solution. We need to determine, is it going to be less than and equal to, or just less than, or is it greater than and equal to, or just greater than? Well, I know since it's a solid line that it's going to be a less than or equal to or a greater than or equal to. Well, the y's that are shaded down here are less than my boundary line. So my final answer is going to have to be all the y's that are shaded are less than or equal to 2. And that should be my final answer. But once again, let's pick a point, plug it in, and test it to make sure that this is in fact correct. So let's go ahead and pick this point right here. It's in my shaded area, so it should be true in this equation. Well, that point is a -2, so let's plug that in. I would get -2 is less than or equal to 2. And that, in fact, is true. I could even pick this point up here, which is 2, and plug that in. 2 is less than or equal to 2. It, in fact, is equal to 2, so that would be true as well. All right, let's move down to our last two here. So these are get a little bit more difficult because these are actually sloped lines, so they will have a slope. So this will be y equals mx plus b form is what we will need to make sure to write these in. So y equals mx plus b. So in our first equation, let's identify our y-intercept, and that's right here. That's at 3. Now we just need to find our slope. So I'm going to go ahead and pick another point. I'll pick one here because it goes right through where the lines cross, and I will count. So in this case, I will go down 1, 2, and over 1. So my slope is 2 over 1. Now I can write my equation in y equals mx plus b form. So it'll be y equals 2x plus my y-intercept, which is 3. Now just make sure that I have listed this as a positive sloping line. And if you'll notice from left to right, the line raises up, therefore it is positive. Now we just have to figure out our inequality sign. Well, we are shading above the line, so we are shading greater. We want all the y's that are greater than. Now is it just going to be greater than, or is it going to be greater than or equal to? Since I have a solid line, it's greater than or equal to 2x plus 3. Now here's where it becomes even more important to do a test point, because we have a little more to think about when we're making this equation. So I'm going to go ahead and pick a random point anywhere, and I'm going to pick, let's just say I pick this point right here. So this point is over 1, 2, so over -2 and up 2. So this point has the coordinates of -2, 2. I'll now plug that into my equation, and it should be true if this equation is correct, or this inequality, I should say. So I'm going to substitute a 2 in for my y, and then I will also substitute in for my x. I will substitute in -2. And then I will just simplify. I'm looking to see that my left side, 2, is greater than or equal to whatever my right side simplifies into. And I have -4 plus 3. One more step, I'm going to have 2 on the left side, greater than or equal to -4 plus 3 is a -1. And in fact, 2 is greater than or equal to -1. And that's the key. Any point I pick in this shaded area must be true in any equation that I make for my boundary line, and that is true. All right, let's do the final one here, and if you'd like to go ahead and pause the video and try it on your own first, go right ahead and then come back to us. Okay, if you did that, then you should have had a y-intercept here of -2, and we'll go ahead and use a blue. So this is -2 right down here. We will pick another point, and it looks like as I move up this line, here is another point that's on the x here where the two lines intersect. So let's count our slope. So in this case, we went down, or I can even go up from here. I could go up 1, 2, 3, 4. So I go up 4. and over from here to here is just 1. And if I look at the slope of my line, it's positive. So writing my equation, I would get y is equal to a positive 4x minus 2, which is my y-intercept. Okay, we're almost done. We need to change the sign, and then we'll do a test point. So I'm looking at my line, and it's dashed, which means then that my sign has to just be either greater than or less than. Well, I'm shading below the line. I'm shading where the y's are less than the line. So y, all my answers have to be less than my line. Okay, and that should be our final equation. Let's go ahead and box this one, and we'll box this one. Now let's pick a test point. And again, it doesn't matter what point you pick to test as long as your test point is somewhere in the shaded region. So I'm going to go ahead and I'll pick this point right here. The coordinates of that point are 4, 3. I went over 4 to here and up 3. And I'll go ahead and plug those in. So substitute 3 in for y, and I will substitute a 4 in for x. And then I'm just evaluating to make sure that the left side of my equation is less than the right side of my equation. 3 is definitely less than 14, so our equation is correct, and I know that I've done a good job. Okay, let's go to our final examples. We have 2 more, and these are systems of inequalities, and this is what you've been recently studying. So let's look at this. This isn't really any different than what we just did, except for that you have 2 lines to consider, and you have an overlapping area that's your solution area. So if I look at this first one, my solution area is right in here. Solution area. That is where my shading overlaps. Okay, if I look at the one on the right, I've got shading in here from the dashed line, I've got shading in here from the blue line, but right down here at the bottom is where I have shading from both. So this is my solution area, and this is where the 2 shadings overlap. Okay, so it's good to first establish that. Now we need to come up with 2 equations here because I have 2 lines. I have 2 different boundary lines. So let's first do this blue solid one. So I just merely need to locate my y-intercept, which is here at -1, and I need to find the slope. Well, it looks like here's a point, here's a point. So my slope is just going up 1 over 1. So for my first equation, I'm going to have y is equal to 1x, or just x, minus 1. Okay, now I need to adjust my equal sign to be an inequality. So I should get, and if I look at where this blue line is shaded, the blue line is shaded above. So all the y's that are greater than or equal to x minus 1 will be solutions. Okay, let's do line number 2, the dash line. So in line number 2, my y-intercept is way up here. So that's if this is 2, 3, 4, 5, that would be 5. And let's find the slope of this one. So if I travel down this line, it looks like here's a point that falls right on the x. So my slope in this case is down 1 over 1, 2. And if you'll notice that this dashed line is a negative sloping line, so I'll want to make sure to write my slope as negative. So my equation is y equals negative 1 over 2x plus 5. Now I just need to adjust my equal sign so that I have an inequality sign. And if I look at what's going on with my red dashed line, it's shaded below and it's dashed. So all the y's that are shaded are going to be less than, just less than, negative 1/2 x plus 5. Okay, our final step here is that we always want to check our solution. So let's do a quick check. This is going to be our check. Let's pick a point in the solution area, and notice we labeled our solution area. So I'm going to pick an easy point. I'm going to pick right here. That happens to be in the solution area, so I'm going to check the point 0, 0 in both equations. So let's test it in this bottom one. So what I get is 0 has to be greater than or equal to 0 minus 1. Well, 0 is in fact greater than or equal to a negative 1. That's what it would be because the 0 is gone. So that checks out. Now let's check it in our bottom equation. So 0 is less than a negative 1/2 times 0 plus 5. Well, anything times 0 is just 0, so 0 has to be less than 5, and it is, and that checks out. So see how nicely it is. Anytime you can use the point 0, 0, it's a nice point to use because then you don't have to do as much math. Okay, let's move on to our final example here. So again, we have a blue line and a red line. So let's look at the blue line first. And my y-intercept is here at 1. And here's another point here. So my slope is going to be down 1 and over 2. But my line slopes up, so it's a positive slope. So writing my equation, I'm going to get y equals 1/2 x plus 1. For my inequality sign, where this line is shaded is below, and it's a solid line. So I will need y is less than or equal to 1/2 x plus 1. Okay, good. Let's look at number 2. So in number 2 is also a dashed line. My y-intercept is also a 1, but let's figure out my slope. So here is a point, and if I look at this slope, I go up 1 and I go over 2. But notice that the line is again negative sloping, just like this one. So we have an equation that's y equals a negative 1/2 x plus 1. And we just need to adjust the equal sign. So where if I look at the shading is below, so it's less than y, and it's just less than because it is a dashed line and not a solid line. Okay, we're almost done. We just need to pick a test point. And if you'll notice that 0, 0 is once again in our overlapping solution area, so I am going to check the point 0, 0. So let's go ahead and plug it in. So in our first equation, 0 has to be less than or equal to 1/2 times 0 plus 1, and 0 then is less than or equal to 1, and that's true. In our bottom equation, I'll plug in my 0, 0, so I get 0 is less than negative 1/2 times 0 plus 1. This cancels, anything times 0 is 0, so 0 is less than 1, and that is true. So I know my equations are good. All right, and that concludes how to write linear inequalities from graphs. So if you have any questions, go back and rewatch the video and then try the practice on the next page.